How is immutability achieved? One of the key elements that make blockchain immutable is cryptographic hashes, which is why blockchain is immutable. The main advantage of hash is that it cannot be reverse engineered. That's the reason why it is so popular. The most popular hash function is SHA-256, i.e., Secure Hash Algorithm 256. There's an input that goes into the hash function with a checksum as the end product. In the below image, we can see how blockchain is disruptive goes as an input, after which hashing occurs, resulting in an encrypted output as a checksum. After hashing a block, the checksum of it is an input to another block, which will generate a checksum as an output. Each iteration here will result in a different checksum every time. In a block, the transactional data is processed with the previous hash along with the metadata and TX data hash, which altogether is hashed. That's why the checksum generated at every block is always unique. This certainly explains why blockchain is immutable to some extent. In this framework, exchanges confirmed by a blockchain network incorporate squares of data implanted with timestamps, which are made sure about by a hashing cycle. It interfaces together and consolidates the hash of the past square. This instrument builds up the ordered chain that joins each square. The hashing consistently incorporates the meta information of the past square while producing another hash for it, which sets up a connection between the square and the chain at that point gets rugged. The facts confirm this is a strong system. In any case, there are a few difficulties that this component needs to survive. Advantages. The biggest advantage of blockchain is that the data cannot be altered, whereas, as seen in the traditional databases, the data can be modified and deleted easily. And if any instance occurs where the data is tampered with, the blockchain breaks. Making changes in both disconnected and live blockchain advancements is very troublesome. When individuals allude to the blockchain as permanent, it implies that it is hard to make changes without conspiracy, not that the information can't be changed. Hence, it answers the question of why blockchain is immutable. Furthermore, this innovation has both positive and negative ramifications for information security. Ledgers that send blockchain innovation can ensure the full history and information trail of an application. When an exchange joins the blockchain, it remains there to portray the record up to that point in time. The respectability of the chain can be approved whenever by basically re-ascertaining the square hashes. If an inconsistency exists between block information and its comparing hash, that implies the exchanges are not legitimate. This permits associations and their industry controllers to identify information dabbling rapidly. This ensures complete data integrity. Thanks for watching. Remember to save the post for easy reference. We are a network that aims to make making an investment decision easy for anyone without experience. Follow us for more.